What if the AI framework that everyone's so hyped about is built on shaky foundations? In the next few minutes, I'm going to dive into Model Context Protocol, also known as MCP, and really uncover where's the true value provided by this new technology, or are you just setting yourself up with more technical debt? Having analyzed tools that use MCP, I've uncovered certain patterns that most developers miss. Stay with me to learn when MCP actually delivers value and when it actually creates more problems than it's worth. Because the wrong choice could be costing you reliability, scalability, and security. You don't want to miss this one. All right, I'm going to just jump in to explain the main differences with MCP and just general agents in general. This is just to make sure it's a bit that we can understand. So on the left here, I've just got a simple diagram just showing agents, tool calls, and memory. And on the right, we see the same thing, but using an MCP. And I want to dive into what's the main differences with this. So let's start with the agent. So with an agent can have multiple different tool calls, and it can use those individual tools to perform a series of tasks, and it's non-defined. So when you send a request down to the agent can choose which tool to use, and those tools can then send a response to the server, and the server can send a response back, and then use that as results and carry on. And you might want to store whatever those results into memory so you can keep iterating on your request. The difference between where MCP comes in is when the agent comes in, it has access still to tools, but it also has access to the MCP protocol. But one thing you'll note is MCP also has its own tools. And what it'll do is before it tries to determine where it wants to go, if it's a tool call, memory, or use the MCP, it will also ask the MCP, hey, give me a list of the tools that you can do with their relevant tool calls and functionality. So from that, the agent can decide, let's say we want to use MCP. So the agent will do a call to the MCP, which MCP will then use the right tool. This tool could also want to access the server by itself to get certain results, and that server will return a result. The MCP might want to store this into memory, and then will return the result back. So one thing you'll note here, the key difference is between an agent using just tools and an agent using MCP is, well, one, the agent on the left is more stateless. So you have an API request, so you asking for a certain bit of detail, and the tool recall will come back with only the result that you're asking it for. With MCP, because we're also storing memory, when we do substantial calls afterwards, we can actually use the memory in MCP to generate a better tool response in the MCP server itself to get. One thing you'll notice, the main difference between agents and MCP is the way the tool calls are actually working, where the agent is we're using an API sort of tool call where things are more stateless. You request certain data and you get a response, and then the state is gone. Where in MCP, your state it remains in memory. When I say state, it's pretty much think about the logs or interaction. It kind of keeps that in memory. So this kind of allows MCP to have additional functionality where it can maybe have better context of what's actually going on and actually choose the right tool within the MCP to give you better results. So the way you must think about MCP is it's a easier way to integrate with AI agents. It needs less configuration than tools because you're not actually making all the API requests yourself. It's built in an isolated MCP server, and the MCP server is responsible for handling the tools and memory itself. So what I was saying before, MCP is a bit more bidirectional, so it keeps context of what's actually going on in the conversation. Your agent will also be keeping conversation history into its own memory. So MCP kind of lives agnostic to your agent and can communicate back and forth, so it's bidirectional. So it's very stateful. And you can do a lot more powerful things in an agentic workflow like this because you don't always have to send the full context of the conversation each time you want to interact with MCP. And this is actually where the true value of MCP comes in. But this is also where we run into some errors or issues with MCP. At a high level, the best way to think of it is its own server. And in that server, you don't always have access to the code, depending on where you got the MCP server from. but it's essentially a little bit like a black box. It will give you some capabilities that it can do for your agent, and that's all your agent will ever know about it. And this is where a lot of my concerns come in with MCP. One is because it's a bit more like a black box, if you do not trust the MCP provider that you're actually using, probably stop using it altogether, because you want to make sure you understand fully what's going on in the MCP. Either that the MCP provides you with detailed logs of what's going on inside, make sure it's transparent, and also is there enough authentication for the MCP server so your data is not getting lost or hijacked by intermediary. So we can see MCP is really powerful. It can do quite a lot. So it's bidirectional by default. So we don't always have to pass the context from the agent or our conversation to the MCP each time we do a tool call. It will have sufficient memory to do more tools and give us better responses because it already has that context in memory. The issue comes in is MCP is its own server. What does that really mean? It might be a positive, but it's also a negative. If you're using an external MCP server and you don't have full transparency of what's happening in that server, you might be just leaking important information. Also, some MCPs don't even have proper authentication built in, and this leaves you open for a vulnerability. There is talk about that you can use OAuth in MCP integration, which will help address some of these concerns. One thing to note though with MCP is it is not that stable yet. It's still very new. We're looking at about a 40% downtime with MCP servers, so it's not really reliable. So if you're trying to build an AI application workflow that's critical, MCP is probably not where you want it right now. All right, so I just want to dive into some slides with the MCP protocols just so we can get a bit more detailed information on each of these. So one is the AI integration problem. So we always feel like we're in a trap of just integrating different APIs to get our AI agents to work. And sometimes our AI agents can only do up to 5 tool calls. So it actually limits the capability. And then we're stringing on multiple different agents just to get a workflow working. It doesn't always work the way we need it to. Sometimes we have to do too many jumps just to get the result. And this is fundamentally where MCP comes in. And this is the issue it's trying to solve. So it's trying to simplify the complex tool integrations, the disconnected AI models, and it kind of promises a standard way to communicate between AI models and tools. It also tries to decentralize on how the customization of AI actually works. So you only have to worry about your agent and what it has access to. And again, it just makes integration between different AI agents seamlessly easy. So let's just have a quick look. So again, pretty much the best way to think of MCP is it's a tool that AI agents can access, but that tool has its own state and can interact with the agent. So essentially, it's an external tool which is integrated with your agent logic. It has bi-directional communication, meaning it will retain information of previous conversations, so you don't have to always pass it full context each time, which can save you effort, and which means you don't always have to pass it the full context each time, which makes an iterative approach with an MCP server that much easier for an agent. Also, it's designed for more non-technical people. They don't have to really worry about the API calls. They just need to know that they're using the MCP server, and the rest will be handled for them. So we've just got a quick example here. We've got a social analyzer MCP tool. We're just giving it the name, and we're just telling the agent that it can use the MCP server to analyze Twitter engagement, and it has this tool and what context it needs to provide. It can do that using the MCP server. So it just makes things a little bit easier. One thing to note, MCP versus traditional approaches, MCP is more of a client server model. It's bidirectional and there's automatic tool discovery. So you're not really maintaining the tools yourself with the agent. You're just making sure it has the connection to the MCP architecture. Sorry, you're just making sure it has access to the MCP that you want to use. And the MCP will handle the different tools that are available to it and communicate that back to your agent, depending on the use case. So the one thing with traditional API integration, so this is what we were mainly using before MCP, is it's direct point-to-point connections. It's a request response only. So if I'm trying to get information about a certain thing, I package my request in a certain format and I get a response in a certain format, and the state is lost. There's no memory. That's the biggest difference here. And traditional API is generally cloud-based. It's more functionally a functional approach, where MCP is a bit more of a server approach with state. And that's one of the big draws of MCP. So we talked about MCP and the problems it really is trying to solve, but what are the limitations? Well, one is because it is using state, we actually have to manage the server. And with the server and state management comes overhead. And this is one of the big problems with MCPs. There's reported up to 43% higher latency in stress tests and 27% more downtime compared to alternative tool calling, and 27% more downtime compared to tool calling approaches for AI agents. Tool discovery could be quite chaotic with MCP. If you've got over 100 tools in your MCP server and you're still using an agent to integrate with it, the agent can actually get confused on which tool it's asking the MCP to actually use. Even just because the MCP has more tools doesn't actually mean the agent will know exactly which tools to choose, especially if tools are very similar. And again, also we've seen in the past, agents are not that great at picking the right tool in general. So by just adding additional tools on top of that, we can see degraded responses. So MCP is not always the solution. It makes certain things easier, but it might also add additional problems when we're doing it. And the next thing is security vulnerabilities. Mostly 58% of MCPs don't actually have basic authentication controls. Again, this is all very new, so people haven't actually got the right structures and protocols to follow yet, but this will definitely decrease as time goes along. And then performance, MCPs don't actually perform that much faster than a stateless application, but you can do more iterative approaches with MCP, like I mentioned before. So one thing to note is we talked about how great MCP is, some of the little faults that have with it, but this is the one point I'm going to drive home when you really need to think about if you want to use MCP in your product. One, is it a critical application? Can you actually forward this workflow to fail and deliver inconsistent results? Because it is still experimental at this stage. And at the moment, we're seeing quite high failure rates using MCP, especially if they're selecting from 10 tools or more. And we also know that users don't really have tolerance for failures, especially if they want to rely on it. You can think of it like a travel agent. If the travel agent gets your accommodation wrong 30% of the time, you'd rather just not ever use that travel agent. And that's the way you should think of your user experience, especially using MCP. So I don't think MCP is where we need it right now. I think it offers a lot of benefits to the problems that I was mentioning earlier, but I think we still have a long way to go. And if you are building MCP, when is the best time to choose it? So MCP shines if you've got a niche tool integration. So MCP really shines for niche tool integration, rapid prototyping. So you don't always want to iterate on the different API calls. It's all handled in MCP. You can use that and then test it with different different AI agents. It's a good way to think of it. But again, it's more on the prototyping stage, not really the production stage yet. And I want to emphasize that point more and more right now until things get a bit more stable. All right, red flags. When to avoid MCP. If you've got low latency requirements, do not use MCP. If it's mission critical, so you can't afford the workflow to fall over, reliability concerns make MCP unstable right now, don't use it. And the other thing is long-term maintenance concerns. We don't actually know how many times MCP is actually going to change in the coming months and how much iterative approach and technical debt you might actually get if we decide to go with MCP right now. And if you do decide, take these considerations in mind and prepare for them. So we know there's a lot of critical improvements needed, simplification of protocol specifications, So what does a road ahead look like for MCP? Well, we know there's a lot of critical improvements that are needed for MCP, especially if we want things to be faster, maybe adding a bit of stateless operations to handle scalability a bit better. We also maybe want an we might also need an MCP Lite version, so it's less it doesn't always just fall over, and we can run just core functionality on it and reduce the latency. So again, we're still early days. This is just like speculation. So what would be my recommendation for a strategic guideline for adoption for MCP? I would say one, limit the scope, use it only for POCs right now. Also, if you decide to use MCP servers yourself and you didn't build them, make sure the MCP is transparent with everything that it does under the hood, or you have access to see what the code is. And lastly, this is just in case it falls over, just plan that MCP might fall away in 6 months and you're not overly reliant on it. So just to recap everything we went, what is MCP in general? You can think of it as a AI tool call, but it has its own memory and it can do its own client server based protocols, and it's bidirectional. And it's a stateful context retention where it can either be deployed locally or on the cloud. And it has its own automatic tool discovery. So it'll describe to the agent what tools it has and what the agent can do with the MCP. And it has a little bit of a black box implementation. So the pros for it is simplifies integrations. It's very easy to put MCP into your agents, but it comes with a few trade-offs right now. One's being high failure rates because it's a brand new technology. Security concerns are something that you should take seriously if you are using it. And one thing is, lastly, if you are deciding to adopt MCP, just know it is more of a POC stage right now. It's probably not meant for production. And as we as the year progresses, we'll see different implementations there, MCP and better standards come out, which might become a bit more useful for the next level of agentic workflows. Well, I hope you found this video useful. Just a brief description of what actually MCP is. I know I was struggling with what's all this hype about MCP and is it even worth it? And there was just a few concerns I had, and that's just what I discovered in this video. And I really hope you found this useful, and we'll see you in the next one.